Hello. In this lecture, I'm going to describe something in mathematics that has caused a lot of confusion and I think has led to many of the errors, including the singularities and infinities of mathematics, um, and has carried on for a long time, and now to clarify the error in mathematics. So math is basically all the language between the two states of absolute nothingness and absolute everything. In the case of this lecture, I'm going to define the concept of nothing as math does and call it zero. And I'm going to call the concept of everything one. Or I could call it infinity or whatever I want, but I'm going to call it one in this example. So 0 means absolutely nothing and 1 means everything. So now let's look at the difference between ratios and division and the decimal system. And here is where the confusion lies, because math has been treating these as the same even though they're different. So if we have a ratio of 0 over 0, what we're saying is if we have no pizza whatsoever, and then I take no slices of it whatsoever, I'll end up with nothing whatsoever. When we do division, we could have 0 goes into 0, and we could say, yeah, well, nothing goes into nothing, and we get 0 back. Or we could say, well, nothing is something, and another nothing something, so if I put nothing into itself, maybe I'll get back the same thing, or that could be 1. We could call it 1 or anything. So math doesn't really have a definition for 0 over 0. And for decimals, it's the same thing. It's really not describable in math. Here we'll take a full pizza, we'll call it 1. And then we'll not take any slices, and we'll keep our whole pizza uncut. So here's one whole pizza, not cut at all. 1 divided, or not sliced at all, the ratio, no ratio taken of it. Keep it whole. But now when we try a number system, and we try and take something that's absolutely nothing and conceptually put it into a pizza. Well, how many nothings of pizza would it take to make a pizza? Well, if I don't have any pizza at all, I'd have to keep putting in nothing to make a pizza, which is nonsensical. So if I keep putting in nothing to get something, it could be infinity nothings to get something, but I probably will never get back a pizza, no matter how many times I try to put nothing back in. How am I going to get back my pizza? So it's kind of undefined by the language, or maybe it's defined as infinity. Again, it's just a problem. But in this case, as a ratio, if I start off with something and I don't slice it at all, I keep it. In this case as well, if I have nothing and I don't touch it, I have nothing. So the ratio is working, but the language is kind of breaking down here. Let's go to the next case. Here I'm going to have a ratio of 0 over 1, which is basically I have nothing and I'm going to slice it up by 1. So if I have nothing to start with and I slice it or do anything to it, because I have nothing, I'll keep nothing. And in the language of math, if I have nothing and I take something and I put it into nothing, well, I can't really put something into nothing, because if it's nothing, then it's nothing. So I stay with nothing, and we'll call it 0. We keep nothing. Now here we have a full pizza, and I'm not going to slice it at all. I'm just going to say, okay, I have a full pizza, and I'm not going to cut it. Like here I'm going to cut it in half, but here I'm just going to keep it full. 1 over 1, my full pizza. And here's division. Well, these are going to represent little pizzas. So here I'm going to have one pizza here. And I'm going to take one pizza here. I'm going to put it into one. Okay, I could take one pizza and put it into one pizza, and I get one pizza. Depending on like how I define my pizza, and that's why I was saying before, I could have said that this whole pizza equals infinite pizzas because I could count as high as I want. The language allows me to count infinitely. So one could have been one, or if I made my language of math, it only went from 1 to 4, then one could have been 4. Or one could be infinity. One becomes whatever value my language counts up to. So one just means the whole thing. And because we could count in our language forever and call that counting forever infinity, that's why I could say that it's infinity, or I could call it 1 if I mean that 1 means everything. So this is what 1 means. 1 over 1 equals 1 into 1 means 1, or the whole thing. In this case defined as 1, or I could have made it infinity. It means the whole thing, because I could count forever. In decimals, this could have been 1, or this could have been 1.000000000, whatever I want it to be. It means the whole thing. Let's go to the ratio for the next one. So before I continue, in this case, the things that work so far is here, is when I have nothing and then I have nothing. These two actually worked. The ratio and the division worked, where nothing meant nothing. And here's another case where it worked, where everything meant everything, where 1 equaled 1 and 0 equaled 0. The other cases are not so well determined, but these two cases are determined. Now we'll see where the problem starts to come into place. Now we have a ratio 1 over 2. I'll take a pizza and slice it in half, and we're fine. Here's a half slice, here's a half slice. Put it together, I make the whole pizza. Now I got a problem. I'm going to try and take 2 pizzas and put it into 1 pizza. Well, what happens? Well, here I was able to do it. So I could take a pizza if it's, because it's itself. It's defined as itself. So yeah, I'm not really taking a pizza and putting into it. It's just the pizza itself, really, 1 over 1. But here I'm trying to take 2 pizzas. Or here, little pizza going into little pizza. It's 1 over 1. It works. This will fit exactly into that pizza. But now 2 pizzas go into 1. No, it doesn't go into 1. It does not go into 1, so I get 0. It's undefined, 0. What's it go into? It goes into 10 pizzas. Our language is based on tens. This is what this means. It means that 2 pizzas goes into 10 pizzas 5 times. And this means that 2 pizzas goes into 100 pizzas 50 times. And 2 pizzas goes into 1,000 pizzas 500 times, but it never went into 1 pizza. So even if I multiply that back 2 times 0.5, I get back 1, but what I'm really getting back is 10, because I'm getting back the same concept as before, which is undefined. And then I get my 5 pizzas over here times 2 is 10. So 1 is meaning the whole thing, which would be 10, because I can never do this. This concept doesn't work. Let's see what happens again. The same problem. Ratio works, 1 over 3. 1/3, 1/3, 1/3. Keeps the whole pizza. Try to put 3 pizzas into 1. It's not happening. I get the same value again. 1 over 2 equals 0. 1 over 3 equals 0. 0.333. What's that mean? 3 pizzas go into 10 pizzas. It never went into 1 pizza. So here's 3 pizzas going into 10 pizzas. Here's 33 pizzas going into Here's 33 times 3, which is, 3 pizzas goes into 100 pizzas 33 times, and 3 pizzas goes into 1,000 pizzas 333 times. So what happens when I try to multiply 3 back? I get the same problem. I never got back into 1 pizza before. I just keep getting back into the 10 pizzas again, or the 100 pizzas, or the 1,000 pizzas, but never back into the 1, so I can't recreate it. That's why I get 0.9999. You can't get back the whole pizza because these are based on tens, and as we can see, it's not working. Until we get to 10, we have the same problem. 2 does not go into 1. 3 does not go into 1. So that's what's going on here. 3 goes into 10 3 times, 3 goes into 133 times, and 1,333 times, but it never went into 1. Never will, and that's why 1/3 equals 0.3333, and if I multiply 3 by 0.3333, I'll get 0.9999. I won't get it back. But if I take the ratio 3 times 1/3 over here, then I get back the full pizza. Because this is talking about 1. And this is talking about 10. So they're two different concepts completely. That's why it doesn't work. Go to 1/4. Same problem. 1/4 works as a ratio. But as a division, 4 never went into 1 pizza. It gets 0. It's undefined. See, 4 pizzas don't fit into 1. How does it work? Well, 4 pizzas goes into 10 pizzas 2 times. And 4 pizzas goes into 100 pizzas 25 times. Or I could use the other trick and I could say, okay, well, 4 pizzas, 4 went into 10 2 times, and I had 2 left over, and then I create another 20 pizzas, and I say, okay, 4 goes into 20 pizzas 5 times. And I get this. But again, this is 25. This is 4 goes into 100 pizzas 25 times. So in this case, the 1 really means 100. Because 4 never went into 1. It didn't happen. It equals 0, just like the other term. So now we have 3 different terms with the same value, which doesn't make sense. A half equals 0, a third equals 0, a fourth equals 0. We see how mathematics breaks down now. Here we have the ratio, which works. 1/5, I take all 5 together, I keep the same ratio. Over here, 1/5 equals 0. It's undefined because you can't put 5 into 1. 5 goes into 10 2 times. And that's what this is saying. Or 5 goes into 120 times. So in this case, 1 doesn't really mean 1, it means 10. Because 1 means the entirety, but in reality, the entirety is going to mean 10 because 5 never went into 1, just like it didn't again. So we have another value at the same. 1/5 equals 0. It doesn't work. It works with the ratio, but not with the decimal. Again, same thing. 6. 1/6. Take them all together, we get back the full thing. 6 times 1/6, the ratio works. But now the number, 1 divided by 6. 6 into 1 doesn't work. Again, 1/6 equals 0. 6 doesn't go in. How does it go? Well, 6 goes into 10. How many times? Once. And it has 4 left over. So we could either say, okay, we'll bring the 4 over, and then 6 goes into 40 6 times. And 6 goes into 40 again 6 times. 6 goes into 40 6 times. Or I could say 6 goes into 116 times. Or 6 goes into 1,166 times, but 6 never went into 1. So that's why when I multiply it back by 6 to try and get back the full pizza, I can't do it. It won't work. This is the problem with math. The ratios are different than division. Now 1/7, same problem. Get another, same value. 1/7 equals 0, undefined. You can't put 7 into 1. It works here, because I'm just slicing the whole into 7, but here I'm actually trying to take 7 things, put it into one object. Doesn't work. What does work is I put 7 into 10. How many times that work? Goes 1. And then if I try and put into 100, it'll work into 114 times. And I could put 7 to 1,142 times, or 10,000, 1,428 times. But you see, when I try and take 7 and I multiply it back by that, I'll get a 0.999 again, because I can't get back here because they're saying different things. And here's the problem. Again, by 8. Got the same value again, 1 over 8. Well, 1/8 works. Cut the whole into 8 slices, we get back the whole. Here, 8 into 1 doesn't work. How does it work? Same thing as the last time. 8 goes into 10. 8 never went into 1, but 8 goes into 10 one time. And then 2 left over, and then you could play the trick. Well, okay, 20. 8 goes into 20 two times. And 4 left over, and then 8 goes into 45 times. Or I could just say 8 goes into 1,000 125 times. But 8 never went into 1. So when I talk about 8 times 0.125 to get back 1, what I'm really talking about is I'm getting back the 1,000, but I'm not getting back this 8 into 1 never worked. It's the same problem. Here it is with 9 again. 1 over 9, it works. Keeps it whole. But here we go, 9 into 1, get the same exact value. Getting the same value each time on the definition. It's not working for the division, but it works for the ratio. 9 never goes into 1. 9 goes into 10 one time. 1 left over. I create another 10 because the system's based on 10s, and it goes in one time. So I get 0.11111. Or 9 goes into 9 never went into 1. 9 goes into 10 one time. 9 goes into 111 times. 9 goes into 1,111 times. But when I multiply it back, I can't get back the whole because it never worked because of this. This just means that I'm getting back what the language told me. I'm getting those 9 pizzas back out of 10, and I'm getting the 9 pizzas back out of 10. I'm just recreating this, but I'm not ever getting back the whole pizza because this is based on 10, and this is based on the true definition of unity, where I'm just breaking it up into 9. And here's using the language, and this is why the language is breaking down. Let's go to 1/10. Here I slice it up into 10, it works. Here we try to put 10 pizzas into 1, same value, 0. Doesn't work. How does it work? 10 pizzas goes into 10 pizzas one time. Or 10 pizzas goes into 100 pizzas 10 times. Or 10 pizzas goes into 1,000 pizzas 100 times. But it never went into one pizza. Now let's see when we go past 10. We'll go 11. 1 over 11. No, it works if I slice up the one whole pizza into 11 slices and I multiply by 11, I get back my whole pizza. But now division doesn't work. 11 never went into 1. And now we have a new thing. Now we try to put 11 into 10, which is here. And look, it's undefined because 11 does not go into 10. So we get that. What's 11 go into? It goes into 100. How many times? 9 times. It goes in 9 times, and I'll have 1 left over, and I'll create another 100 pizzas. And 11 will go into another 100 pizzas 9 more times. And 11 goes into 100 more pizzas 9 more times. But it never went into the one pizza. And that's why I can't get back the whole thing, because this is different. It's based on 10 system. These are undefined. And for the last example, we'll do 1 over 12 just to show how it's going to continue the same story. 1 over 12 is defined properly if I use the ratio and I cut this up into 12 slices. But over here, if I try to put 12 pizzas into 1, it's undefined. Or 12 pizzas into 10, it's undefined. Here it is. 12 into 1, nope. 12 into 10, no. How does it work? Well, 12 goes into 100 pizzas 8 times. And 12 goes into 1,000 pizzas 83 times. Or 12 goes into 10,833 times. But that's different. By multiplying by this by 12, I don't get back the 1. I get back this language of mathematics. And that's why I can't get back the whole. Because 12 never went into 1 in the first place. And 12 didn't go into 10 in the first place. And that's why these values 0.0, 1 over 11 was the same as 0.0 for 1 over 12. Meaning it didn't work. Just like all these other values ended up the same too. So mathematics is giving us the same value for different functions. I have 1 over 2 equals 0. So 1 over 3 equals 0. 1 over 4 equals 0. 1 over 5 equals 0. All these are different values. I'm getting the same answer. 1 over 6 equals 0. 1 over 7 equals 0. 1 over 8 equals 0. 1 over 9 equals 0. 1 over 10 equals 0. And then now I'm going to go past 10, and now we have a new thing, because now we're on this language of tens, and I got now 11, 1 over 11 equals 0, and 10 over 11 equals 0, because it doesn't work either, because now I'm above 10. And again, 1 over 12 equals 0, it doesn't work, and 12 over 10 equals 0, it doesn't work. Not until I get to the hundreds now does it make sense. The next values of 10. So that's the problem with math. Ratios and division are totally different entities. One's based on unity, the whole thing, and the other one's, the language is based on 10 systems, so you can't get back what you started with. And that's why the proofs never worked. So in summary, ratios are defined because they preserve the unity of the structure, where division is only defined at the states of 0 and 1. If you remember back at the beginning of the lecture, that the two states where division and ratio stayed and worked were these states. When I had nothing at all, 0 over 1 and 0 over 1, or when I had the whole pizza. That was unity, and that was complete nothingness. So mathematics is describing the nothingness and the everything in between the nothingness and the everything. But that's why the language isn't working, because it's treating ratios as the same as division, and they're different entities, and we can't get back the nothingness and the wholeness once we start dividing it. That's why we get a half times a half times a half, and we just get a half, a quarter, an eighth, a 16th. We can't get it back because they're different entities completely. And so unity is only preserved when there's absolutely nothing or absolutely everything, and that's it. And that's really what the problem is with mathematics, is until we see that's the issue at hand here, then we can figure out the rest of what's going on with the language. I'll have another lecture on prime numbers, which is exactly the same problem about breaking up unity and why prime numbers occur when they do. And it has everything to do with just when unity occurs. And that's it. Mathematics is trying to equate two different concepts as being the same when they're not. And I thank you very much, and we'll see you the next lecture. Thank you.